My name is Adyant and this is my final DSF project, the word clock. So starting with the circuit, as you can see this is the base clock of the circuit. If I switch it on, this has a time period of 3 seconds. So this resistor R1 and this resistor R2, both are potentiometers, have been adjusted so that the clock has a time period of exactly 3 seconds. The output from this clock goes to these counters, and these counters count 100 of these time periods. So this AND gate here recognizes the 100th time period of that clock and sends out a pulse every 5 minutes. Every 5 minutes sends out a pulse to this counter, which then counts the states of the finite state machine. There are 12 states in the finite state machine, and it gets reset every 12 at 12, so which is 1100. So the output from the counter, which are 4 variables S3, S2, S1 and S0, go to this region of combinatorial logic. So these are a set of AND and OR gates that decode the 4 finite state variables to output 9 variables that output the minutes. So as you can see, there are 9 outputs in the clock that correspond. So as you can see, there are 12 states, and that's 5 minutes past 1, 10 minutes past 1, quarter past 1, 20 minutes past 1, 25, half past 1, and then it's 25 minutes to 2, 20 minutes to 2, quarter to 2, and 10 minutes to 2, 5 minutes to 2, and then 2 o'clock. So these are the 12 states. There's a second FSM that increments the hour. So this takes the output from 2 and it goes into a second counter, which goes into a separate chip that returns a 1 hot vector for each of the hours, and each of the hours go into an output here. Now for the output, as all the logic, all the combinatorial logic is done on 5 volts, and the required output for the LED is 12 volts. Each of the LEDs get an input of 12 volts, and they're connected to ground via these bipolar junction transistors, these BJTs. And what these BJTs do is they technically act as a switch. So when you saturate the current through them, that is the 5 volts that goes into the collector. The emitter is connected to ground, and thus the current flows through the LEDs, lighting them up. So the function of these BJTs is just to act as a switch, which converts the 5 volt logic to 12 volt outputs. Each of these BJTs has 2 resistors connected to it. The resistor of 1000 ohms connected in series with the LED, and a resistor of 100 ohms that's connected in series with the 5 volt logic. So that is my clock.